Okay, here we're discussing gravimetric analysis. So we discussed precipitation reactions a couple days ago, in which we described how if you combine certain ions together, they'll form a solid in solution, and then they can be filtered out and be masked out as well. We're going to use that in determining then the percent composition of silver in an alloy. So here you see we have this silver alloy. 1.1264 grams of this silver alloy. And the question is, what percent of all these grams is actually silver? So in order to determine this, we want to isolate that silver from the copper. And so you can do this by first dissolving both of those substances in nitric acid. So if you take a silver-copper alloy and dissolve it in nitric acid, you'll get silver nitrate, which is soluble, it's aqueous. And you'll get copper nitrate, also soluble. Remember, all nitrates are aqueous. As well, you get a highly acidic solution, and brown, yellow gas, nitric oxide release. Actually, nitrogen oxide released. Nitrogen monoxide. Okay, so you dissolve all this with nitric acid, and you have this homogeneous solution then of all of these things. Now you want to isolate that silver from the copper, and so you can do this by taking advantages of differences in properties. For example, silver precipitates upon contact with chloride, whereas copper does not. So you can add an aqueous solution of sodium chloride, excess sodium chloride. And so that chloride, it combines with the silver, and you get, therefore, silver chloride solid, precipitate. And so you're going to get a cloudy solution at that point. All these small particulates, those are solid silver chloride particulates. And so now you want to separate the silver chloride from the rest of the solution. So to separate a solid from a liquid, you can use filtration. So pour this cloudy solution through filter paper. And so the solid will get caught in that filter paper, and the liquid will flow through. And so therefore you can take this solid silver chloride and you can dry it by putting it in the oven. So that all the water is evaporated, and it only leaves those 0.1375 grams of silver chloride. So now you have the mass of silver chloride. How many grams of just silver were present in your solution? So this is where we get into doing some math. So let's see, how do we go from grams of one compound into grams of another? If you're going to convert between one type of compound and another, in all cases, you need to go to your happy place. Go to the land of the mole. So convert into moles of silver chloride, and then you can go into moles of silver, and then into grams of silver. All right, and so we see we actually collect 0.1375 grams of silver chloride. How many grams of silver were there? So we go from grams into moles. And then what's the mole-mole ratio between moles of silver chloride and moles of silver? Well, each mole of silver chloride has 1 mole of silver in it. And so the number of moles of silver originally in your alloy is going to be the same as the number of moles of silver chloride collected, presuming that we had 100% reaction of both the alloy with the nitric acid and 100% reaction of the silver nitrate with the sodium chloride. So that all of our silver was actually turning up as silver chloride. Okay, so we know the number of moles of silver, and therefore then we know the number of grams of silver. And so you should find that the number of grams of silver is 0.1035 grams of silver. So what percent of the mass of the entire alloy was silver? It's the mass of silver that you have now determined there was over the mass of that alloy. So the mass of the silver we now know is 0.1035 grams. And the mass of the alloy we know originally was 0.1264 grams. And then you can take that ratio and multiply by 100%, and you get 81.88% of that alloy was silver. All right, thanks guys for watching.